What we're going to work on in this video is how to solve simple log equations. Now let's make sure we understand what to call the different parts of a log. This right here is the base, and that's the parameter. So this is a function, right? Log b is the name of the entire function, and x is what we are plugging into it. Now the basic properties of a log is that a log undoes an exponent. So do you see how we have an exponent over here? If the base of the exponent matches the base of the log that we're applying to it, they cancel each other out. Same thing here. If the base of an exponent and the base of the log that is in the exponent match each other, they cross each other out, and we just get x. So just like multiply undoes a division and add undoes a subtraction, a log undoes an exponent and an exponent undoes a log. Now let's work on trying to solve this problem. What I want to do is I want to change this problem from a compute problem into a solve problem, meaning that I'm going to make this equal to a x. I'm going to introduce a variable, and then I'm going to cross this out. Now, once I have this problem, what I want to use is convert this into an exponent. Now let's sort of review how to solve an exponent equation. Now, when I'm trying to solve something like this, what I want to happen is I want the left side to have the same base as the right side. So since we have a 3 over here, I want the left side to have a base of 3. And if you ask me 3 of what is equal to 9, well, that's 3 squared. Once the bases match, we can cross them out. We get x is equal to 2. So what I want to do with this problem is I want to cancel the log by applying an exponent to both sides. Oh, I'm sorry. Make this a 3. Make this side a 3. Now, this 3 will cancel out the log. So this 3 here will cancel out that log. And now we'll get 9 is equal to 3x, which is pretty much the exponent equation problems we solved in the previous section. Now, in order to get rid of this, get rid of the bases, I want these two sides to have the same base. So I get 3 squared is equal to 3x. And now I get x is equal to 2. Now, let's do the same thing on this problem over here. I'm going to apply the base, 25, to both sides. So now, since this base and that base are equal, they cancel each other out. And I want both sides to have, I guess, the base of 5. So we'll make this 5 to the 1, and we'll go 5 to the 1 is equal to 5 squared x. So this 5 squared is equal to the 25. When I have an exponent of an exponent, I multiply. And then I remove the base, and I get 2x is equal to 1, so x is equal to 1/2. Now, one way to try to trick you is to give you something that has a fraction in it. So let's do what we did over here. Let's get rid of the logs by applying an exponent to both sides. The exponent cancels out the log, and now I have 1 over 8 is equal to 2x. I want both of these to have the same base, which would be probably 2. So first I want to bring the 8 up to the numerator, and I do that by using a negative exponent. This -1 means change levels. Take it from the denominator to the numerator. Now I want to match the base at 2. So this 2 cubed is equal to 8. And then when I have an exponent of an exponent, I multiply them. And now I have x is equal to -3 after we cancel out the base. Let's get rid of the log by applying the base of 3 to both sides. And then this base and this log will cancel each other out. Now, here's the little trick. 3 to the 0 is equal to 1. In fact, anything to the 0 power is equal to 1. And now we get x is equal to 0. Now, just so you know that log of 1 of any base will always be equal to 0. But in case you can't remember that, now you can figure it out. Now, until now, the x has been on this side. What we're going to do now is work on problems where the variable is in the base. Now, all these problems are solved pretty much in the same way. I want to get rid of that log. And the opposite of a log is an exponent. So we base both sides, right? This base same as that base. So now this will cross out with that, and I get 64 is equal to x cubed. Now, this is where this problem changes a little bit. You have to sort of remember how to solve a problem that has a cubic in it. So the way to get rid of a cube is to cube root both sides. And the cube root of 64 is 4. And these two will cancel each other out. Okay? The reason why the cube root of 64 is 4 is because 4 times 4 is 16. 16 times 4 is 64. So let's do another example of that. So when we look at this, let's get rid of this log by applying the base to both sides. So now this log and that base will cancel each other out, and I get 9 is equal to x to the 1/2. Now, in case you forgot, this is the same thing as square root of x is equal to 9. And the way you get rid of a square root is that you square both sides. Okay. Now, so now we've solved problems where the variable was here or the variable was the base. Now let's work on problems where the variable is where the parameter is. And again, all these problems work exactly in the same way. The first thing we want to do is get rid of the log. So now these two things cancel. And then 2 cubed is equal to 2 times 2 times 2. 2 times 2 is 4, times 2 becomes 8. Okay. This problem is the same type of problem. Let's get rid of the log by applying a 5 to both sides. So now x is equal to 5 to the negative 2 power. Let's make that into a positive exponent. So we will change levels. Now the funny thing, after we solve all these problems, the two problems my students usually get are the original sort of properties. So when I give you these problems, this is typically what my students get wrong the most often, mostly because it's so easy it's hard. This base and that base, they cancel each other out, so that's equal to 4. There's no manipulation needed. In the same way here, this base and this base will cancel each other out. So you get 4. Thank you for watching this video.